Example of ASI's array module firmware. What I have installed here is this is just a MS-2000 standard stage. We're doing a single slide system, and the ASI controller has the ability to run both a array of predefined coordinates, or it can run a series of like you could say, okay, build an array where give me 10 steps to the right, 1 step down, 10 steps to the left, and do that with the following spacing, and then just save the array. Or that's a array value that calculates on the fly in the ASI's computer. Or you can just drive to the positions you want and add them into a list. In order to trigger the list to move, we have this particular camera has a breakout box which can be enclosed in an enclosure, because this is obviously not how we want to supply it, but we have the camera, power supply, firewire, and the trigger output. Trigger output goes to our box, and from here we have a sync signal. So this signal is firing a TTL, and the TTL is going into the ASI controller on the back. So I've set up the ASI controller with a code string. Basically all it's doing at this point is waiting for the TTL signal. Of course, there's some more, we can do a full closed loop system. There's two connections on the ASI. We have input and output. So in the lower position here we could do, and probably should do for this type of a setup, a don't take a picture until the stage has stopped moving kind of a command. We don't have that right now installed, but what we're looking for here is top speed. How fast can the stage respond to camera triggers? So what we're going to do is we're going to run a live on the camera, and we'll see how fast this thing can go. So I'm going to hit the live window, and the stage is moving. These are just random positions that I assigned to look at frame rate. And we can see that the images we're getting are non-streaking. So this is because the camera is acquiring quickly enough to reduce any sort of streaking that we get in the image. And this is a pretty small pattern, so we're just repeating it over and over again, which is why we're seeing what we're seeing. And that's it.